This is the first of a couple of AP free response questions. This one is from 2003, a long time ago, but it is a gas law, and pressure problem. So let's take a look. It says a rigid, which means that the volume doesn't change, 5.00 liter cylinder contains 24.5 grams of nitrogen and 28 grams of oxygen. Calculate the total pressure in ATM of the gas mixture in the cylinder. Okay, now we know number one here that if we're given grams, this is something that goes way back to the first trimester. If we're given grams, we can always find the number of moles, which is what we need because we're going to do PV equals nRT, and what we're looking for then is going to be the total number of moles of both nitrogen and oxygen added together to solve this equation. So it says calculate the total pressure, which means pressure equals, and then it's going to be the total moles of O2 plus the total moles of N2, like that, times R times T, and divided all of that by the 5 liters for the volume. So how do we find the number of moles of O2 and the number of moles of N2? Well, that's actually not too bad. That's something we've done a long time ago. I got 25 grams of nitrogen like this. I go over 1, and then nitrogen, and it's N2, which means that if it's 14 for just one N, it's 28 for two N's. So that's going to be 1 mole of N2 is 28.0 grams. Look on a periodic table, find N, and it should say 14.0, or, yeah, no, it's 14.00067. For the number of grams per 1 mole of nitrogen, and then to make it N2, we simply multiply by 2. So that's where this number comes from, the periodic table. Okay, when I divide these two here, it looks like I get something that is very similar to 0.875 moles of N2. Good. I do the same thing for oxygen. Oxygen is 28 grams, so 28 grams of O2. Now because it's O2, exactly like with my N2, I get 1 mole of O2 is equal to 32.0 grams of O2. Okay, and as it turns out, oddly enough, we get the same number of moles of oxygen like that. So far, so good. All I have to do now is plug it into my equation to find out what my pressure is. So let's go ahead and do that. So pressure equals, I'm going to scroll. Now I'm going to try and keep it here because I have all of my information up here. Total mass in, okay, so the only thing I need to remember is 298 K for temperature. It's atmospheres, and it's volume of 5 liters. So let's do it. So this is going to be pressure will be in atmospheres. That's what I'm looking for. Volume is 5 liters. N is these two added together, which would be, who knows, 1750. That would be 1.8750, yeah, grams. We're on. Number of moles for the mixture. My R value, because it's in atmospheres, is 0.0821, and my temperature is 298 Kelvin, like that. So what is my pressure? I'm going to use that equation up there. I got my 1.750 moles, total moles, times R. That's an 821 times 298 K, like that. All divided by 5 liters. Okay. Once I do all of that, I should end up with something that looks very similar to 8.56 atmospheres. Okay, that was just letter A. Let's see what it says for letter B. So for letter B, it says the temperature of the mixture of the cylinder is decreased to 280. Calculate each of the following: mole fraction of N in the cylinder and the partial pressure in atmospheres of N2 in the cylinder. Okay, now this is actually going to be not a difficult question, simply because the first part has nothing to do with the temperature. We know what the number of moles are. So there is something called mole fraction. Mole fraction looks like this. If we're talking about mole fraction, let me do that the right way there. Of N2, it is the moles of N2 divided by moles of N2 plus moles of O2, since those are the two things that are in there. So that basically means 0.875 moles divided by our, now we add them all up, 1.750 moles of the mixture, which, in case you're not sure, gives us an X of 0.500. So 1/2. Okay, so that's the first part. This would be I for a letter B. Maybe I should have done a different color. Oh, here. Let me change it to a different color. Yeah, that's right. We can do whatever we want here. Properties. Let's just go black for now. Good. And then I'll switch here. Now let's take a look at I2. That right there. So for I2, it says the partial pressure in atmospheres, but we have a new temperature. So we are going to have to do this all over again. So P total is both of them together, and it's going to have to be, again, the N total, like all of the atoms, all of the gases together, RT with our new temperature, all divided by V, like this. And when I plug this in, I get my 1.750 moles times R is still 0.0821, and then my new temperature is 280 Kelvin, like that. And then all of that is still divided by my 5 liters. So what you get with the P total, like this, is 8.0 atmospheres. And if we have a mole fraction of 0.5, which we got up here, right there, then all I have to do is take my pressure of nitrogen is simply equal to the P total times the mole fraction, which means 8 atmospheres times 0.500, which is going to equal 4.0 atmospheres. And that's our pressure of N2. Okay, that's pretty good. I think I'm going to stop here, and we'll do AP problem 2003 Part C will be the next part.